I'm sure you are aware of the third interstellar object in our solar system, 3I Atlas. But there's a new study that tries to see if the object has had close encounters to other stars in our galaxy. What you, of course, can do is assuming that it had the same speed and direction in the past where it's coming from. So you can kind of extrapolate its trajectory back in the galaxy. Researchers looked at a dataset of ESA, of the Gaia satellite, that has 30 million stars in its database. And the researchers looked at stars that were closer than 1 parsec, which is kind of 3.2 light years, and they found 25 stars. The researchers made a table of 20 single encounters, of which the distance was less than 1 parsec of 3I Atlas. So here you see the 20 stars, and each Gaia star just has a number. You see all the numbers here. Let's see, they are ordered in the how close they are to 3I Atlas, or how close they have been in the past. So the closest is this first one, with ID starting with 5 ending at 8. Time ago, 1.62 million years ago. So then it was close to this star, and the distance was around 0.08. So that's like 3. How much light years is that? Wait a minute. I will calculate how much light years that is. 0.88 times 0.088 times 3.2, about a quarter of a light year, which is quite close, but not very close. A quarter of a light year. So it hasn't been really close to the stars. They didn't find really close encounters with this method. A quarter of a light year is still very far away. Let's see when it has some kind of close encounter. 0.33. Oh, wait a minute here. 0.03 million years. So that's 30,000 years ago. So 3I Atlas has not seen any other star in 30,000 years, at least according to this database. 0.03. Then let's see, 200,000 years ago it saw this little star. Actually, this is a binary star, likely. So maybe it has seen 2 stars 200,000 years ago. Then 330,000 years ago, 580 years ago, 580,000 years ago. The farthest away in this dataset is 4.3 million years ago. I don't think you can really say anything about stars much longer ago, because then the movement of the stars themselves in the galaxy are scattered too much through the galaxy to make a good estimation of the trajectory encounters. Like the more you go in the past, the more uncertainty you have, of course. But still, I think this is quite a good study, especially to see that 3i Atlas did really not visit any nearby stars in the history. If you assume it has this trajectory that it had, but if it has no other propulsion system, then it's quite a good approximation, because if there are no influences of stars nearby, the trajectory is not altered, of course. Like the comet just goes straight according to Newton's third law that says it needs some kind of a force to alter its trajectory, and so since it did not really encounter any stars, we can assume that it has been on this trajectory for millions of years. Then the researchers also found that these stars did not really alter the trajectory or the speed of 3i Atlas significantly. So they didn't have really a lot of effects by gravitational forces on 3i Atlas. So this is not kind of a nice paper, because I will show it again. Search for past stellar encounters and the origins of 3i Atlas, Kuo et al. From the University of Shanghai. Shanghai University.